Good morning, guys. Uh, this is the second part of the 3.1 notes. Hopefully, the first set of notes made sense. You guys kind of were able to follow along and complete a little bit of the first assignment. So, today we're going to talk about correlation a little bit. And when correlation, if you think of the word correlation, correlation basically means how closely things are together or how are they related. In stats, we define correlation with the letter R. And by definition, correlation addresses, oops, bear with me. Correlation addresses strength and direction of a linear association. Does not address form. So if you remember from yesterday, these three words should look familiar. Strength, direction, and form were all terms we use to describe or interpret scatter plots. So again, the R value, which is correlation, you can address strength and direction. Is it positive or negative? That's direction. Is it strong or weak? But you cannot address form. You use it for two quantitative variables. Quantitative, which is what we're going to be working with in chapter 3. And kind of my overall definition here is correlation is the average of the products of the standardized scores. So we can use correlation or our R value to talk about strength and direction. We can never use correlation to talk about form, and it is kind of the average of the products of the standardized scores. Some characteristics of correlation is the correlation is always between -1 and 1. If your R value is less than 0, it means your direction is negative. If your R value is greater than 0, that means you have positive association. And again, it can never be less than -1 or greater than 1. So your R values are always going to be somewhere between -1 and 1. If it's negative, it's negative association. If it's positive, it's positive association. If your R value is close to 0, that means the strength is weak. So remember yesterday, I kind of talked about strength, and I said later on we would be able to, I would give you a little bit more information on strength. So if you have an R value that's close to 0, it doesn't mean it has to be positive. Negative 0.1, positive 0.1, that means your strength is going to be weak. If R is close to negative or positive 1, that means the strength is strong. So 0.9, negative 0.9, that would refer to the strength as being fairly strong. Close to 0 is weak. Close to positive 1 or negative 1 is going to be very strong strength. All right, next page here, or actually same page. Which association is more linear? One with r equals 0.5 or one with r equals 0.9? Okay, now again, they're asking you for more linear. Linear has to do with form. Remember, form is linear or nonlinear. If you look back up the notes, your r value does not address form. So you can't say that the association is linear or nonlinear and use your r value as evidence, because your r value doesn't address form. So you can't determine the form of a relationship using only correlation. R is a supplement for a graph, not a replacement. So you can say that the association is strong, or it's weak, or it's positive, or it's negative if you know your R value. You cannot say it's linear or nonlinear because you can't determine form using only the R value. Okay, now I'm going to go through a little activity here that we normally do in class to kind of help you guys understand R value a little bit. So this is called the correlation guessing game. I'm going to do a few of them, and then I'm going to pause in between and kind of let you guys take a guess on your own on what you think the R value would be. Okay, so again, now remember, go back to, you're going to want to be looking at this section right here in the characteristics. So you're going to be trying to guess the R value based on the scatter plot I put up. So remember, your guess has to be between -1 and 1. If it's negative association, it's less than 0. If it's positive association, it's greater than 0. Close to 0 is weak. Close to plus or minus 1 is strong. So if I put up a scatter plot of 25 points, this one's kind of hard to start with, but your first determination is the direction positive or negative? Now I can't really write on this, but if you kind of think slope and you look at this top point and this bottom point, you can kind of see that it's kind of a negative slope. Well, I would think. But then again, if you look at this point and this point, it's positive. So this one, first of all, this one's hard to tell if it's positive or negative, which means your answer has to be close to 0, because regardless, it's weak. You can't really tell if it's positive or negative, that means your association is weak, which means it's got to be close to 0. So I'm just going to leave this as 0 as a guess, and I'm going to click check guess, and then it's going to give me my R value. I think it's slightly positive, like 0. I'll go 0.05. Let's see if I can do that. 0.05. And I was wrong. Good start. So it's slightly negative, but fairly close to 0. And again, I think it's because of this point and this point. All right, that was not a good start. Let's try another one. Okay, this one's a little easier. So this one, clearly, you have an outlier here, but all of these points clearly have a positive direction, which means my slope or my direction has to be positive, which means my R value has to be greater than 0. Now remember, you're between 0 and 1. If the form is really strong and these points are really close together, you're going to be closer to 1. If you're kind of weak and they're scattered a little bit, you're going to be closer to 0. I'm going to go 0.65 as my guess, because I believe that these are fairly strong. And remember, the highest I can go is 1. So a straight line would be 1. If all the points were on a dead straight line, that would be 1. Might be a little higher. It might be like 0.7. We'll see. Hey, that's better. 0.65 too. All right, I redeemed myself. Another one. Okay, so kind of walk through what you guys see in your head here to yourself. First thing is the direction positive or negative? And again, direction kind of think slope. Clearly, my slope is negative. Okay, now this seems like a pretty straight line. Most of these points are on a pretty straight line, which means your form is going to be pretty strong. So I'm going to go, now again, it has to be negative because my slope's negative. So I'm going to go negative, let's see, negative 0.85. I'm going to go really close to negative 1 because those points are pretty close to on the same line. And that one's really strong. So I was even a little low. So negative 0.97, that's about as strong as you can get because you can't go any lower than negative 1. So your R value would be negative 0.973. All right, I'm going to put this one up here. I'll let you guys look at that for about 30 seconds and see if you can come up with a guess for your R value. So I think this is positive. It's slightly going up from left to right if you look at most of these points. But it's not really on a straight line like the last one, so it's not going to be 0.9, 0.8, 0.7. I'm going to say this is closer to 0.3. And again, I might be a little bit off. Oh, that's really weak. So 0.063. So that's kind of lower than I expected. So that's pretty much close to 0, which means it's barely positive, but not very strong at all. All right, you guys try this one. So again, positive. Strength is fairly strong in through here. I would say these four are a little bit off, so I'm going to go 0.75. Oops, messed that up. This one, negative 0.8. Negative. My association is negative, so I'm going to guess negative 0.85. Again, they're kind of on a straight line all the way through. I don't have any outliers. And That was pretty close, negative 0.9. So that's just a few examples of kind of how the R value works and kind of relating that into the characteristics of the R value. Okay, back to our notes here. Is correlation a resistant measure of strength? So we've talked about resistant measures all year. And if you remember, resistant measures have to do with outliers. Correlation is non-resistant because the R value is strongly affected by outliers. So we did this with mean, median, standard deviation. If outliers influence the statistic, then they are non-resistant. If outliers do not influence the statistic, they are resistant measures of strength. So because outliers play a role in calculating the R value, therefore they are not resistant. Okay, how do you calculate correlation? So I'm going to put up a complicated looking formula. And then normally this is the part where I say, hey, your calculator will do this for you. Only this time I'm going to say, hey, Desmos will do this for you. So your R value mathematically is 1 over n minus 1 times the sum of all this fun stuff. Oops, these aren't supposed to be here. Okay, and this may look complicated, but if I tell you that xi is data point and yi is data point, these two things should actually look familiar. These are your z-score calculations. If you remember z-score formula is data point minus the mean divided by standard deviation. So you're taking a data point, x, minus x bar, which is mean, and you're dividing it by standard deviation. Now the reason why you have two of them is because you have an x and a y point in a scatter plot. So if you think of the scatter plot I made in Desmos yesterday, you have an x coordinate and you have a y coordinate. So if you find the two z-scores, multiply them together, add them all up, that is basically how you calculate R value. Now again, the nice thing is you don't have to worry about this because I will show you how to do this in Desmos with our next example. Okay, so this is kind of a very important example. You guys know by now when we get to important examples in your notes, they come up quite a bit. So I'm going to walk you guys through this. We're going to review how to make a scatter plot, review how to describe and interpret a scatter plot, and then talk about how to get your R value and what that means. So I'm given data on the lengths in centimeters of the femur and the humerus. And I have 5 points. You have your x coordinates and you have your y coordinates. Okay, make a scatter plot, describe what you see. So the first thing we're going to do is make a scatter plot. Okay, now again, remember we're going to try and do these in Desmos. I'm going to go to Desmos, and I'm going to insert a table. So go to your plus sign, go to table, and then enter your data. 38, 41 is my y coordinate, 56, 63, 59, 70, 84, 72. And finally, 74, 84. Oops, this is supposed to be 84. 84, 74. Okay. Again, nothing showed up in my Desmos because I need to scale this a little bit. So I'm going to kind of zoom out so I can see my points like this. I'm going to go into my settings up here in the top. I'm going to label my X as femur. And my Y-axis as humerus. And that should be pretty good. Now again, a little review. Don't connect my points, and I have a brief little scatter plot of 5 points. So describe what I see. All right, so just briefly, I'm going to talk about direction, outliers, form, and strength again. Jot a few things down in my notes. So my direction, clearly, my direction is positive. I have no apparent outliers. My form is pretty linear. So again, positive direction, no outliers. Points are pretty close to on the same line. And then strength. Okay, so now remember, yesterday I just kind of guessed on strength. Now you guys kind of have tied in the correlation in R value to strength. So if you remember the little activity we just did, and I told you to guess the strength of these 5 points, first of all, it's positive, so it has to be between positive 0 and positive 1. And then these points are pretty much on a line. They're not really scattered, so I'm going to say my strength is very strong. Strength. And again, now I'll be able to, if I had to guess an R value, so I'm going to estimate. And since I said very strong, I'm going to estimate that my R value is 0.9. Because it's very, very close to 1 because it's very strong. So, and again, if you guys had to do this, you guys would have to kind of write out sentences and then add in the context, but I'm kind of trying to get through this briefly for review here. But very strong estimate. My R value, remember, ties into strength and direction, but not form. Okay, now part B says, find the correlation for these data. Does it agree with your description in part A? All right, so now here's where you got to watch carefully. Once you have a scatter plot, and you guys are going to be doing this a lot, on the next line, you need to enter kind of an equation. I'm going to flip my screen around here. Okay, so this is very important. It's kind of like y equals mx plus b, but it's a little different. So you're going to take the y coordinate, and I'm just going to copy and paste y1. Okay, and remember the 1's a subscript. So the easiest way, if you have a computer or even on your phone, if you can copy and paste it, that would be great. And then you are not going to put an equal sign. You are going to put, I believe it's called a tilde in English, which is a little squiggly line. Now on my keyboard, that is up to the left of the number 1, and I needed to click Shift or caps lock. Okay, so kind of foreseeing problems here. Don't put equals. You need to put a tilde, and on my keyboard, it's up to the left of the number 1, and I needed to click Shift to get that little squiggly symbol in there. Okay, and then again, it's kind of like a mx plus b, so I'm going to put m next. Only instead of x, I'm going to use x1 because that's the notation in my table. So I'm going to control copy x1, control paste, and then put in a plus b. Okay, so it's very, very important that you guys get this into Desmos. Y1, which is the Y title of your table, tilde, M, X1, which is the X coordinate in your table, plus B. Now, what that puts into your scatter plot is what's called a line of best fit. Okay, so in your scatter plot, I will put this in your notes. Okay, so Y1 tilde M X1 plus B, that inserts what's called a line of best fit, which basically is a linear line to represent your scatter plot. Okay, normally that's not there, but again, that's called a line of best fit. Now, the nice thing for today's lesson is in Desmos, it puts in your R value. R equals 0.9941. Okay, so the correlation, or your R value, is 0.9941. And that pretty much agrees with my description in part A. My R value has to be positive, which it is. And it is very, very, very close to 1 because my strength is very strong. Okay, that's going to kind of wrap up today. So biggest things is, again, try to get familiar with Desmos. Make sure that you are able to insert a table, insert the y1 tilde mx1 plus b, and that will calculate your R value for you. Keep working on direction, outliers, form, and strength, and how to interpret scatter plots. And then what does your R value mean? What does it mean with direction? What does it mean with strength? And remember, your R value never addresses form. All right, that brings you to your next assignment, which is 58, page 159, 15 through 18, 21 through 24. Let me know if you are having issues accessing the textbook or issues with anything else that I need to know about. Okay, continue to check your email. Try not to fall behind with your assignments. I will give you some further direction on how we're going to turn in assignments, so on and so forth. All right. I hope you guys have a great day, and I will talk to you soon.